Okay, so hopefully we can hear things very well. Right, so we're going to pick it up from where we left off with the geometry, because yesterday, a bit later on in the evening, we actually looked at parallel lines and the relationships that exist between parallel lines. So we're just going to quickly recap on these, all right, and that is the fun concept, right? Yeah, so if we have parallel lines like this, okay, the F letter tells us about angles that are equal, but it's angles that are equal in the following way. We say corresponding because on top of this parallel line there is an angle, and then in the same position on top of this parallel line there is an angle. So we say that these two angles, we say they are corresponding. But in saying that these angles are corresponding, guys, we are basically saying that on top, that's what corresponding means. But because the lines, we'll say this is line AB, and then we'll sign this as line CD. So because AB is parallel to CD, we say that on top we are equal. These angles are corresponding. Okay. Then on the bottom of this line, and then on the same position, the bottom of the other line, we say bottom, these angles are also what we call corresponding angles. So it must be angles that lie on the same side of what we call the transversal line. So AB and CD, if they are parallel, we can then say that the corresponding angles, and by corresponding we mean top, bottom. So the top angle here and the top angle there, we say they are equal. Why? Because the lines are parallel. The bottom angle here and the bottom angle here, we say that these angles are equal. Why? Because the lines are parallel. So corresponding angles, whenever we identify angles that are corresponding and we say they are equal on the basis of lines that are parallel, the reason that we write down, guys, and we need to be very, very clear with the reason that we write down is we say corresp angle. The short form of the reason is corresp angles, and then we state the lines that are parallel, and that's basically how we account for the reason why we are saying top angle equal, bottom angle equal. Reason being the lines are parallel, therefore the angles are equal. Okay, yeah. Then that basically gets rid of the corresponding angles relationship. Okay, then we have this relationship between these parallel lines. We call these lines that are parallel. Inside these lines we have these angles. Okay, these angles are not equal, but these angles, we say that because the lines are parallel, we say that the angles, they are supplementary. In other words, the two angles, they add up to 180 degrees. So these, we call them co-interior. Co has something to do with togetherness, you know, and then interior has something to do with inside. Okay, the interior of anything is the inside of something. So together inside. All right, so these two angles, we say that the sum of these angles will give us 180, only and only if the lines are parallel. So whenever you use or you state that, you must understand that it's co-interior angles, and don't forget to state the lines that are parallel. For short, we say co-int angles for short, right? And then you state the lines that are parallel thereafter. Okay, that's the U shape. So U shape is for co-interior angles. Angles together inside, they sum up to 180. F shape is for co-interior, is for corresponding on top, on the same side of the transversal line, or bottom on the same side of the transversal line. So top we are equal, bottom we are equal. Bottom angle is equal to bottom angle, top angle is equal to top angle. That's corresponding F shape. Co-interior, together inside the parallel lines, we say that these two angles, they sum or they add up to 180. Then the last relationship for parallel lines that we have is the Z or the N shape, all right? And it's angles that are basically situated in that position. We call these angles alternate angles. Okay, alternate angles. Okay, and what do we know about alternate angles? They are equal. All right, so corresponding angles, top and bottom are equal. For alternate angles, those angles in that position are equal as long as the lines are parallel. But then co-interior angles, they are not equal. The sum of the angles though gives us 180 degrees. So that's something we need to note. Okay, yeah. And whenever we use this particular reasoning for this particular diagram, we basically write alt angles and then we state the lines that are parallel. Okay, thank you so much, Pembelani, for the you awesomes. I really appreciate it, sir. And thank you so much for the likes, guys, so far. The 36 likes, very much appreciated, and the love as well, Pembelani. So N shape, Z shape, alternate angles. These angles, we call them alternate, but we say they are equal only if the lines are parallel. So these three relationships are important for us to know. We need to know that they are corresponding angles. Top is equal to top, that is corresponding as long as we are on the same side of the transversal line. Bottom angle is equal to bottom angle as long as the lines are parallel. That is corresponding angles, and whenever we use that reason, we say corresp angles for short, and we don't forget to state the lines that are parallel. This U shape is for co-interior angles. Co-interior, together inside the parallel lines, we say that these two angles, they add up to 180. And whenever we use that to find a missing angle, we say co-int angles for short, and then we don't forget to state the lines that are parallel. Okay, then we have the N or the Z shape, which basically means those angles that are situated in that position. We say those angles are alternate, and whenever we use this particular approach to find a missing angle, it means that we state the reason and we say alt angles for short, and we state the lines that are parallel. In the same vein, there are cases when we are required to prove that lines are parallel. Okay, whenever you are asked to prove, guys, that lines are parallel, this time around you are not asked to find the missing angles, but rather you are asked to prove that lines are parallel. I just want to expose you to like 2 or 3 scenarios of what I mean by that. Let us say we have a situation like this. You have P, S, you've got D and T, and then they give you here an angle 50 degrees, and then they give you another angle here which is 50 degrees, and then they say to you, is PS parallel to DT. So you look at this diagram and you're like, are they kidding? They're asking, is PS parallel to DT? So when you look at it like physically, this diagram, you are like, this does not in any way look like parallel lines. But in order to basically conclude as to whether the lines are parallel or not, we need to actually look at the angles that we have been given. So we have to then accept the fact that we are given a 50-degree angle. This 50-degree angle is at the bottom of this line PS. It is situated on this side of the line. But there's another 50 degrees that is situated where? At the bottom of DT. And it is also situated on this side of the line. So what then can we conclude about these two angles? The position of these two angles gives us what kind of relationship? The position of these two angles gives us which kind of relationship, one, and two, what is the value of these two angles? And what can we conclude about the value of these two angles in conjunction with the relationship that these angles actually have? So what do we call these two angles? Obviously, the two angles are the same, they are equal. But because of the position of these angles, we call these angles what kind of angles together? What do we call them? Okay, so what you can see here, guys, is that if you were to trace out, let's just see it in green, you can see Moss. We kind of have a F shape that sort of like comes about. We can see that this is a bottom angle and this is also a bottom angle. So we have a bottom situation of angles that are equal. So we can then conclude and say PS is parallel to ST. Why can we say PS is parallel to ST? It is because we have identified corresponding angles that are equal. We say PS is parallel to ST. Why do we conclude that PS is actually parallel to ST? It is because these two angles are actually corresponding angles, but they are in actual fact equal. Therefore, PS is parallel to ST. On what basis? It is because the corresponding angles are equal. Right? So we use corresponding angles equal as a reason for saying PS is parallel to DT. To prove that PS is parallel to what? To DT. Okay, so I said ST, but it's PS is parallel to DT. PS is parallel to DT because 50 degrees and 50 degrees are in the position of corresponding. And these corresponding angles are what? They are both equal. Therefore, we can say PS is parallel to DT. DTY, because corresponding angles are what? Are equal. Just want to look at another scenario very quickly. Let's say we had a scenario like this as well. Here we were given 150. Here we were given 30 degrees. And then let's say we were given AB and CD. And then they ask you, is AB parallel to CD? Now, on the basis of the drawing, AB and CD do not look parallel at all. So that's why we then have to investigate the angles that we have. So if we take a closer look, we are like, okay, what do I see here? I see 150 degrees. What do I see there? I see a 30 degrees. What relationship does 150 and 30 degrees have, seeing as though they lie, both of them, between these two lines? What relationship does 150 and 30 degrees possess, seeing as though they lie in between these two lines, plus they are on the same side of this transversal line? Yes, Benzo, these two angles have a co-interior relationship. That's what they have. They have a co-interior relationship. But what do we discover about these co-interior angles? When you take 150 and you add it to 30, what do you get? 150 plus 30, guys, gives you what? Okay, so I'm hoping you guys can see. 150 and 30 gives you 180. Thank you so much, Benzo. Okay, 150 plus 30 gives you 180. Therefore, what can you say then about AB and CD? Well, we can conclude that AB is in actual fact parallel to CD. Why? The reason is because they are co-interior angles that are actually what? Supplementary. That is the reason. Why is AB? We were asking, is AB parallel to CD? Now we are concluding that AB is parallel to CD. On what basis? On the basis that we can see that there are co-interior angles that are in actual fact supplementary. These two angles do add up to 180, and because these co-interior angles are supplementary, we can then conclude without a shadow of doubt that AB and CD are actually parallel lines. We did not know that before, but now we know it for a fact that AB is parallel to CD. Why? Because co-interior angles are what? Are supplementary. Okay, so this is the second way of proving that lines are parallel. When you find co-interior angles that are supplementary, you can conclude that lines are parallel. When you find corresponding angles that are equal, you can prove and state without argument that lines are parallel. The third example that I want us to look at is this one. You have 70 degrees. You have 130. You have PS. You have NM. Let's put L in there, and let's put V in there. So now what we want to prove is whether PS, all right, is parallel to NM. Is PS parallel to NM? Now, in order to prove that, I am going to first check the given angles that I have. I have a 70 degrees here. Okay. I have a 130 degrees here. When I look at these two angles, there is no evident relationship between these two angles that can lead me to conclude that PS is parallel to NM. So that means I have some groundwork to do. There is still calculations that I need to do that will assist or help me, that will assist and help me. Now, sorry guys, I just want to fix something because I'm realizing now that there's something here that is a bit wrong. This 130, let's change it to 110 so that it can be able to yield the required result. So once again, if we look at 70 and 110, there is no relationship that we know of that exists between 70 and 110 that could help us to conclude that PS is parallel to NM at the present moment. So there's a bit of work that we are going to do, and this bit of work that we are going to do is the following. This 110, all right, is next to this angle. all right, which when I call it, I'm going to say is angle VLM. And it most I can say this angle is angle VLM with a cap on top of L, or I could say the angle is angle MLV. Okay. Now this angle VLM, which is this one, is next to or adjacent to 110. So 110 degrees together with this angle as angles that are next to each other that are lying on a straight line. We call these adjacent angles. They are next to each other. They lie on a straight line. If we want to calculate angle VLM, what do we do? So Benzo in the comment section is helping us out there and is saying 180 minus 110. So these two angles are angles that lie on the straight line. So we can say that VLM, angle VLM plus 110 degrees as angles that are next to each other, adjacent. We can say these two angles, they add up to what? 280 degrees. What is the reason? Angles on a STR line. Okay, we're writing our reason in accordance to the acceptable reason document. So angle VLM plus angle, this one, 110 degrees is equal to 180. Angles on a straight line. Then if we make angle VLM the subject, we take 110, it transposes to the right. That means 110 becomes negative 110. Then our final calculation, what is 180 minus 110? It is 70 degrees. This angle VLM, I can update my diagram and put 70 degrees. I've calculated the angle. Okay. Now that I have this angle, check the relationship that I now see because of the update in getting angle VLM or angle MLV, if you want to call it that. This angle has a relationship with this one. What is that relationship? We call these two angles, what kind of angles? Yes, Benzo. Benzo is like with me. You're flowing with me there. These two angles are alternate angles. Guys, please understand this. Alternate angles exist whether lines are parallel or not. This word alternate angles has to do with the position of the angles. So the minute you have a Z shape, the position of these angles is what we refer to as alternate angles. But the minute we find that those alternate angles are in actual fact equal, I repeat, the minute we find that those alternate angles are in actual fact equal. So in other words, I now know that angle PVL is equal to angle VLM, and they are both 70 degrees. Do you know what I can conclude then? Because the relationship that exists between these angles is alternate, I can conclude the following, that PS is parallel to NM. Why? Because alternate angles are equal. That is why. PS is parallel to NM. Why? Because my alternate angles are in actual fact equal. And their equality then says to me, PS is definitely parallel to NM. So remember, the initial question was asking me, is PS parallel to NM? I saw PS, I saw NM, I initially had 70 degrees, I had 110, and I was like, okay, How am I going to say PS is parallel to NM, yet I'm given 70 degrees and 110? Well, we took it one step at a time, and what did we do? We saw that this 110, even though we can't see a relationship yet between the 70 and 110, we looked at 110 and we saw, we can find the angle that is next to 110. Why? Because this line is a straight line. And it being a straight line, when you have adjacent angles lying on a straight line and they complete 180 degrees, meaning they complete the straight line, you can take angle VLM, which is the angle you want, add it to angle 110, and then you can say it's equal to 180 and give a reason angles on a straight line. You transpose 110, angle VLM gives you 70 degrees. So we update that this is 70. Now that we have angle VLM being 70 degrees, we can see that there is a direct relationship that exists between PVL, this angle, and VLM. They are both 70. But what else do we know about these angles? They are alternate angles. Why are they alternate angles? It's because they form that Z shape. They form that Z shape. You see that Z shape. Look at it, guys. You see that Z shape. The position of the angles means alternate. Therefore, because these two angles, angle PVL and angle VLM, are both 70, we can then conclude that PS is parallel to NM. And what is our reason? Alternate angles are equal. Ontatile, you are 100% spot on. So Ontatile in the comment section is saying, sir, you can use vertical angles, or be more specific, Ontatile, it's not vertical angles, it's vertically opposite angles. Let's say what we mean and mean what we say. So Ontatile is saying, you could have done this question differently, and I agree with you, Ontatile. That's why geometry is such a beautiful topic, because you can approach it in different ways. If Ontatile had decided to do that question, the same question, okay, let's put V there, put L there, this is 110. Ontatile is bringing to our attention that, sir, I could have thought of 110 having a relationship with this angle. And guys, is Ontatile right in thinking of that relationship? Definitely. If this is 110, the relationship that exists between 110 and this angle VLN, the angle VLN is equal to 110 degrees. Why? Why are they equal? It is that X, which basically means vertically opposite. 110 is vertically opposite to VLN. Therefore, VLN we would have said is 110, and then we write our acceptable reason. Vert op angles equal as per the exam guideline or the acceptable reason document, because we do not just carelessly write reasons, we write them in accordance to the acceptable reason document. VLN is 110. Why? Because it is vertically opposite to this one. We know that vertically opposite angles are equal. So then that is 110. And then Ontatile is saying, knowing that, we can see that 70 and 110 are having which kind of relationship? They are both in between these two lines. Which lines? PS and NM. So we call these two angles what kind of angles? 70 and 110. What types of angles do we call these two angles together? Together inside the lines. We call them co-interior angles. Very good, Benzo. We call them co-interior angles. Why are we calling them co-interior angles? It's because of their position. They are inside two lines. If they are inside two lines and the two angles actually add up to 180, in other words, they are supplementary, what can we then conclude about PS and NM? Okay, because now we are seeing that VLN plus PVL, all right, which is basically 110 plus 70 degrees, give us what? 108. You see, therefore we can conclude that PS is parallel, guys, to what? To NM. When you write your reason, you must say coint angles, sub, coint angles, sub. Why are you saying coint angles, sub? It's because the co-interior angles are supplementary. Co-interior angles are supplementary. That is the acceptable reason that you write to prove that lines are parallel. So I need you guys to lock into this, that whenever you are required in a question paper or in a exercise to prove that lines are parallel, you have three things or three ways that you can look at the question and try and answer it, with the reasons being the following. One, you can either look for corresponding angles that are equal. If you find them, then you can conclude that the lines are parallel. Or two, you can find co-interior angles that are supplementary. If you find them, you prove that they do add up to 180, then it means that these lines are in actual fact parallel. Reason, coint angles, sub. The third and final thing that you can look for is alternate angles. If you find them, you can conclude about the lines and then give the reasons as alt angles equal. I'm going to go to the document that is the acceptable reason document and read for you what it says. 3. If the alternate angles between two lines are equal, then the lines are parallelly. 2. If the corresponding angles between two lines are equally, then the lines are parallel. Okay. 3. If the co-interior angles between two lines are supplementary, then the lines are parallel. So you have these three that you use when you are trying to prove that lines are parallel. These three are used when you want to prove lines are parallel, whereas these three, alt angles stating the lines that are parallel, corresponding angles stating the lines that are parallel, co-interior angles stating the lines are parallel, these are used when you want to find a missing angle. And you can clearly see that the relationship is one where you have co-interior relationship and you are missing an angle. So you use the statement with this reason to then be able to find what is missing. So please, guys, differentiate between the reasons used when you want to prove that lines are parallel and the reasons used when you want to find a missing angle, yet you can see either a relationship where parallel lines are given and you want to find things that are of that nature. Okay, want to take a screenshot? Go ahead, have fun. You want to take a screenshot? Hopefully, guys, the screenshot can screenshot, because as I said to you, these are very critical. I must say, it is when learners don't understand the basics about this, then that the geometry becomes complicated. It's not complicated. The geometry is simple, it's sweet, it's beautiful, it's easy, it's nice. But we need to first understand the basics. You know? Yeah. These are Euclidean geometry basics. I am seeing people saying, I'll show you the screenshot of the reasons as well. Don't worry. I see people asking me what grade. Guys, this is not for a particular grade. If you are in grade 8, 9, 10, 11, 12, you are in the right place. Doesn't matter whether you feel like you know geometry, you feel like you just want me to get to the grade 12 geometry. Guys, I am going through the basics for everyone because I don't care. Even grade 12s, they mess up the basics that are basically basic. So we need to first understand the basics, all right? Then the acceptable reasons, please guys, these ones, okay, I've covered these ones, okay? If you go to my YouTube channel, the first video I did on Euclidean geometry basics already covers angles on a straight line, which we basically use whenever I want to find a missing angle for angles that are lying on a straight line. This second reason I explained as well, that we use this one whenever we are asked to prove that a line is straight. Guys, not all lines are straight. Okay, sometimes they can ask you to prove. Look at this. Look at this. If the adjacent angles are supplementary, the outer arms of these angles form a straight line. Okay. YouTube link is in the bio, guys. YouTube link is in my bio. It's also Maths is a Game. I'm basically using the same emblem. Maths is a Game is basically the same emblem I'm using right throughout. So the most recent video that I posted was of the live lesson I did. I think it was 2 days ago. I did a live lesson on Euclidean geometry basics, and I started out with angles on a straight line, adjacent angles supplementary, angles around a point, and vertically opposite angles. So I did these 1, 2, 3, 4. But in conjunction with that, we also started out with some nice basics about what is an angle in actual fact. How do we define an angle? How can we identify an angle in a given diagram? How to identify the different types of angles that we find. You know, what is a line? The different types of lines that we have. And then we also looked at triangles, different types of triangles. So we're getting into the basics, just the basics, guys, because I'm telling you, the strength in geometry lies in the basics. Okay, strength in the geometry lies in the basics. So I am just letting you know, just from the get-go, strength lies in basics. Okay, strength lies in basics, not in trying to complicate life and trying to be complex. Yeah, but even the complex problems, they borrow their strength from basics. Okay, yeah. So yeah, I think parallel lines, we have basically sorted out the whole idea on parallel lines. Okay, now let's move. I think now we can go on and look at triangles, because I think parallel lines, at least the basics is done and through. Okay, let's try and look at triangles, because triangles is also worth looking at, and we need to look at that very closely, you know. So if you bust out that document, the one I was just referring to not so long ago, a few minutes ago, this document really helps. This one, it helps a lot, this guy. Okay, let's look at this. All right, and let's try and represent these things in a diagram. So the first statement for triangle says the interior angles of a triangle are supplementary. The interior angles of a triangle are supplementary. Look at the 3 reasons that you can use that are acceptable whenever you are using this to validate interior angles of a triangle are supplementary. You can either use angle sum in a triangle, or you can use sum of angles in a triangle, or you can use int angles triangle. Okay, all of these basically validate the statement the interior angles of a triangle are supplementary. Right? Diagrammatically, this is what this looks like. If you have a triangle is ABC. What that simply means is angle A plus angle B plus angle C is 180 degrees. And always you can either say 1, angle sum in triangle. Don't complicate life, guys. Angle sum in triangle, acceptable reason. Or you can say sum of angles in triangle. Don't complicate life. or you can say that. Or lastly, if you don't want to, you can say int angles triangle. That's one of 3 acceptable reasons, guys, that you can use whenever you want to basically give the reason for saying interior angles of a triangle are supplementary. On Tatile, where can you get the document? The document is found, you can go online, for instance, and type in the acceptable reasons. Or whatever grade you are doing, guys, this is something I can recommend. If you are in grade 10, all right, starting from grade 10, you can just go and type in grade 10 examination guideline for mathematics. What that will do, it will give you the entire document of the exam guideline. What it does, the exam guideline, it gives you per topic that you cover in grade 10, what are the most important aspects for the purpose of the exams, the important aspects that you need to make sure that you understand and fully understand well. It also gives you a mark breakdown of the different topics and how much each topic, basically counts in an exam, so that you know where to focus your attention and you know where to focus your attention the most for the purpose of marks. Then also thirdly, it gives you like the cognitive levels at which exams are basically asked. Like when you have exams, obviously there's a level at which questions are asked, so it's nice to know the percentage at which different questions will be asked. And then lastly, it will also give you the document, because it contains, the exam guideline itself will contain the acceptable reason document for Euclidean geometry and maybe other important resources as well. So it's a PDF document. You can just type there on Google. You will definitely get the PDF document for exam guideline. It will be there. You can just click on it and then you can download it and use it. Print it if you want to, use it as much as you possibly can. And especially when you're doing geometry, it doesn't make sense to me that a geometry, exactly, thank you Benzo just put the link there. That one will give you the grade 12 exam guideline, but even the grade 12 exam guideline will have a section where it will basically cover the acceptable reasons for the different shapes that you have. So now then, when you have that printed out, you can use it in the classroom as well and keep yourself in check. You can also paste it up on your wall so that you can continuously have the reasons, the statements in your face, all the time, because that really helps a lot if you have that. Okay, so the interior angles of a triangle are supplementary, guys. That's what that means. It means angle A plus angle B plus angle C, they add up to 180 degrees, and that's very nice and straightforward. Let's look at number 2, the exterior angle of a triangle. Now I need to explain this one. When they say the exterior angle, please guys, understand which exterior they are talking about. The word exterior means outside. So this is an outside angle. It is outside of the triangle. But there's a special thing about this exterior angle. It says the exterior angle of a triangle is equal to the sum of the interior opposite angles. So let's check this out. If you have a triangle ABC, okay, let's just say that's ABC, and then that's obviously D. This line BC, in order for us to qualify this as that exterior angle we are referring to, it has to be a extension that is produced from the side. I repeat, CD must be an extension, but it must be produced from the side, meaning it must be in the same horizontal line. Okay, so this angle, we call it angle ACD, or we can say it's angle DCA, or we can say it's angle DCA, or we can say it's angle ACD. You see, these are things that I explained in my first video for the first live lesson on Euclidean geometry basics about how to name or identify an angle. Angle ACD, the middle letter denotes the angle. So if you use the cap on top of the letter, That's one way of notation for the angle. Or you can put the symbol. This L kind of looks like an L, but it is a symbol that means angle. Angle DC. The middle letter refers to the angle that is specifically we are looking or referring to. So please guys, ACD, this angle is what we call our exterior angle. But it is only truly the exterior angle if it is in line with the side of the triangle. If it is in line with the side of the triangle. Guys, the minute that exterior is not in line with the side of the triangle, like for instance here, ACD, this angle, that is not the exterior angle we are talking about. So this one is not, this one is. Okay, please guys, the exterior angle, it must be in line with the side of the triangle. So BC, okay, CD must be in line for the angle ACD, that is the exterior, to be the actual exterior angle. If it's not, then it's not. Mukundi, like I said, this is for all grades. Okay, this is basics for all grades. So you're in grade 11, you are in the right place. We're eventually going to get to that place that you want specifically for the things that are added on in grade 11. But for now, high basics, my guy, or basics, my girl. All right. So angle ACD, the side that basically makes the exterior angle, the extension must be in line with the side of the triangle. Please, let's take note of that. So this is angle ACD, the exterior angle. Okay. Yeah. So yes, on Tadile. Therefore, if we look at the statement, the exterior angle of a triangle is equal to the sum of the interior opposite angles. Now, we are talking about angles that are inside, whose sum is equal to the exterior angle ACD. What are these interior opposite angles? It means this angle and that angle. So we say angle A plus angle B is equal to angle ACD. This angle A, these are the two interior opposite angles. It is not angle A and this one. It is not angle C and angle B. It is angle A and B. So when you come from angle A and B, it should basically be leading you to the other angle of the triangle, and then outside you should see the exterior. 2, go to the other one, outside is the exterior. 2, go to the other angle, outside is the exterior. So that's how you identify the interior opposite angles. Angle A plus angle B is equal to angle ACD, or you can say angle ACD is equal to angle A plus angle B. Then our reason, guys, the acceptable reason is X angle of triangle. X for exterior, symbol angle of triangle. That is the acceptable reason. Nothing more, nothing less. Okay, I hope we understand that. So I repeat again, the exterior angle of a triangle is equal to the sum of the interior angle A and angle B opposite angles. Okay, and I said this one is the true exterior, this one false exterior. This one, it is not the true exterior angle. Why? Because it is not in line with the side of the triangle. Let's check if people understand this. Let's say I had a triangle and I'm asking now, this is C, B, A, and let's say that's D. My question is, Do we have an exterior angle here for this triangle? And is that exterior the true exterior angle? Maybe firstly you can tell me, do we have an exterior angle? Okay. Do we have an exterior angle? Yes, we do, right? Okay. Then what is the exterior angle? What is the exterior angle if we have it? What is the exterior angle in this situation? Yes, beauty. I mean, yes, we do have an exterior angle because it's in line with the side AB. Very good. What is the exterior angle? Ntatile is saying angle DAC. Beauty, we can't say angle A. You see now in this situation, we need to be very specific. We need to use our naming of the angle and use the appropriate 3 letters to identify the exterior. Remember, if you say angle A is very broad. Okay. This whole entire 180-degree straight line is angle A. Some people could say the entire 360 around is angle A. So angle A is too general of a angle to basically say it is the exterior. We need to be very specific about what is the exterior angle here. So we use the letters, guys. This is angle either DAC. We know that we put a cap on top of the actual angle, or we could say angle DAC. Sorry, no. We put this one, then obviously there's no need for the cap. Okay, very good, beauty, very good. So angle DAC, definitely in that way. Or we could say DAC. Or we could say CAD, or we can say angle CAD. I hope you guys are with me with this. So please, to say angle A, angle A won't work because angle A is not specifically the exterior angle we are talking about. Okay. Yeah. Then the next question I want to ask, what are the 2 interior opposite angles that this exterior angle is equal to? What are the 2 interior opposite angles? Because remember, we say the exterior angle of a triangle is equal to the sum. The exterior angle of a triangle is equal to the sum of the 2 interior opposite angles. So what are the 2 interior opposite angles? That's fine, beauty. I'm glad I could help you save that mark, because the more marks we save, the better. Okay, retention of marks is very important. Anachi must say definitely angle B and C. You are saying, Ontatile is saying B and C. All right, I think we can see what are the 2 interior opposite angles. Yes, C plus B. Okay, I'm glad you guys are not mentioning anything about A, because if you said A, I was going to cry. Tears, not of joy, but of sadness and deep loss. Like, it would be like you guys have basically just sent a very important person in my life down 6 feet under, and those wouldn't be tears of joy. It would be tears of deep loss and mourning and sadness. So you guys definitely angle what? Angle B plus angle C, and we can do that very freely and say angle B, because it's angle B alone that is here. Angle C, it's angle C alone that is there. Okay, yeah, so angle B plus angle C, and then our acceptable reason, no doubt, exterior angle of triangle. Remember, in geometry we always accompany a statement with a reason. No reason oftentimes leads to no marks. Sometimes no reason sometimes leads to a loss of a mark. So we can't afford to not write the acceptable reason when the statement is 100% correct. Okay, so that's another thing we need to ensure that we actually do. Let's look at another triangle ABC. No, we'll get there, beauty. We'll get there. Just for now, I want you guys to first understand the concept. We'll get to the numbers and all that fun. For now, I just want the concept, okay? The next statement in your acceptable reason document says, the angles opposite the equal sides in an isosceles triangle are equal. I repeat, the angles opposite the equal sides in a what? Triangle in an isosceles triangle are what? Are equal. The angles opposite the equal sides in an isosceles triangle are equal. The angles, okay, that are what? That are opposite what? The equal sides. So that means in a triangle where sides that are equal are given to us, what can we write as a statement? In a triangle where there are sides that are equal, what can we write as a statement? We can say angle who? Angle B plus who? Angle C. Because AC is opposite angle B, AB is opposite angle C, and they are both having equal sides. So what does the statement say? The angles opposite the equal sides in an isosceles triangle are what? Are equal. Yeah, of course we can't say this, right? So what we say is angle B is equal to angle C. Okay, I was just writing that there for the sake of writing it. You can say angle B is equal to angle C. Why? Our reason that they are saying we should actually write down is angles opposite equal sides. Okay, I do know some learners, they actually write equal as in like the symbol equal instead of equal, and I think there's definitely a consensus of accepting a learner's answers when they do say angles up and then they write instead of equal then the word, and they write equal the symbol. So angle B we can say is equal to angle C. What's the reason? Our angles, which is angle B and angle C, they are opposite what? Sides that are what? That are equal. Okay, this symbol means that AB is equal to AC. Okay, so therefore we can conclude that angle B is equal to angle C, and the reason that is accepted is angles opposite equal sides. 4. We are given triangle DEF. Angle E and angle F are equal. Lungambuyisa, the base angles of a isosceles triangle are equal. That reason has actually been put to bed. Its funeral was conducted in the year 2014. It was unfortunately laid to rest because of some complications that reason had with its heart and its mind. So it was officially laid to rest, unfortunately, in 2014. It is a very sad loss, but it's a loss that we've come to accept. So we don't no longer use base angles of an isosceles triangle. Sadly, my beautiful people, it is something that we have come to accept. But with that being said, and as sad as it may be, what has emerged or has been resurrected is this beautiful, amazing reason of angles opposite equal sides. It's embraced nationally. When markers mark exam papers at the end of the year for grade 12, it is the reason that is acceptable because it basically is part of the examination guideline, and therefore whenever a learner has seen that the angles opposite equal sides in an isosceles triangle are equal, the acceptable reason that that learner is supposed to write is write angles opposite equal sides. So there is hope yet. Okay, I hope you guys are with me there. All right, and that is I'm just gonna put it straight to you guys. That is the value in attending my live lessons, because me, I will tell you not only the things that basically any typical tutor will tell you, but I will also tell you the things that are born because of the experience of being a marker and having had the opportunity to have a reasonable number of years in the teaching fraternity, teaching and also marking exam scripts in your exam centers for grade 12 at the end of the year. So it's informed by those things. So you will get the value that you need from being able to attend my sessions because of that. Okay. Let's look at this one now. All right. So I hope that's clear for all of us. Now look at triangle DEF here. We have triangle DEF here. Angle E and angle F, they are equal. All right. So the theorem statement that I want us to look at here is this one. This is for all grades. Person who was asking me what grade, all grades, guys, all grades. I don't care what grade you are in. If you are here by mistake or by luck or chance, you are in the right place. I don't care what grade you are in. If geometry is something that basically gives you nightmares, then you are in the right place. And the sides opposite the equal angles in an isosceles triangle are what? Are equal. The what? The sides that are opposite what? Equal angles. So here we are. Angle E and angle F are equal. Does that make sense? So what can we conclude here? That ED is equal to FD. ED is equal to FD. Why? Okay. Sides opposite equal angles. You see now we are using the reason. It's like the converse or the opposite. This one, we had sides that were equal. We then identified angles that are equal. And we said angle B is equal to angle C. The reason was angles opposite equal sides. Ne? Essay Lunga Mbuyes. Essay. The exam guideline is obviously relevant to essay learners. So I'm guessing, yeah, it's relevant to essay learners, and I'm appealing to my essay audience. Yeah. So angles opposite equal sides. This year, ED is equal to FD. I think any international learner that is here will then have to obviously go and look at conditions as per their country and basically what is acceptable. All right. Here in essay, when it comes to the reasons, we are very strict, and we sort of like, conventionally are using, so that there can be commonality amongst all learners. Teachers should basically expose learners to the exam guideline. It's a national document. Everyone should be able to receive it and use it for the purpose of making sure that they are able to excel in exams end of the year or during the year, even during tests, Yeah, Lungambo, yes, that's the thing. Here there's been, discussions, talks, conclusions that have been made. That's why this thing is available for all the learners in the country. So if the reasons are not correct, then you see there can be problems there and there. Right? Though in certain cases there is leniency when they mark, but as a matter of like expectation, when I teach learners, I really make them understand that it's conventionally we need to all try and stick to. All right. Obviously, there's room there and there. I mean, there's certain things, certain deviations that can be within reason that are acceptable. But I mean, yeah, they shouldn't deviate too much. Yeah, we try and establish the standard, and then we say to people they must stick to the standard. Anyways, ED here is equal to DF, right? Why is ED equal to DF? It's because these sides, they are opposite. They are opposite what? Angles that are what? That are equal. Okay, we were given those angles, they are equal. So we say ED is equal to DF. Thank you, Una, for the rose. We say ED is equal to DF, and the reason is sides opposite equal angles. Okay, so as I said, some people, they write down the equal. Okay, where can you get the acceptable reason? Please, man, go to Google, all right, and then type their grade 10 exam guideline for maths. Okay, it can be any, actually, grade 10, grade 11, your maths exam guideline, you know, and go and grab that guideline and use it, you know. You guys are going to be writing exams in June. Just make sure that you get that thing. Okay. How long? Gambo, yes. He wants to challenge. Hi, my guy. Go ahead. Please do that. All right. Because I think whatever you said earlier on has the grounds. You said, like, even if it's mathematically correct. Because at the end of the day, if it's mathematically correct, there shouldn't be, like, you know, but like I said, man, these guys, the people that are up there, the higher ups, they are the ones that basically make legislation and then they rule it into practice. But please, Lunga, if you can do that, do it and save us, please. Save us. For now, we have to conform, but save us. All right. ED is equal to FD, guys, in this situation, because sides are opposite equal angles. Let's move on. I think you get the point. Number five. Want to tell me about this guy? Number 5. We are still looking at triangles. Who is this guy? Science shouldn't be political. Sholung. ABC, triangle ABC, guys. Triangle ABC. What do we know about a right angle triangle? There's a theorem here that I'm trying to look for from all of you, because all of you should be able to look at this and be like, oh, okay, that theorem, that guy, you know, there's that guy who is basically people's nightmare, you know. He starts with a P, that guy. It's like a python. Yeah, beauty Lamini, look at you, Pythagoras theorem. Definitely that guy. Okay, what does Pythagoras theorem say? Okay, so Pythagoras theorem says in a right angle triangle, the square of what, guys? The square of what we call the hypotenuse side. Hypotenuse is the side that is directly opposite our 90-degree angle, our right angle. We call this guy Mr. Hypotenuse. Hypotenuse is the longest side of your triangle. So theorem of Pythagoras says the square is AC squared, because AC is our hypotenuse, so we say AC squared. The square of the hypotenuse is equal to the sum. Sum means plus. Sum of what? The square of the other two sides. Our other two sides are AB and BC. So the sum of the square of the other two sides is equal to the square of the hypotenuse side. We call that Pythagoras. So whenever you use Pythagoras, it's so important that you do write the statement as per the theorem, but then you also must indicate the reason, Pythagoras, or you can say theorem of Pythagoras. So I usually say to my learners, for the sake of saving time and not spending too much time writing a reason, Pythagoras, it would simply be the simplest and most quickest way to basically write the reason. Okay, here is it. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Pythagoras, or theorem of Pythagoras. This in a right angle triangle. So this is only applicable in a right angle triangle, and the right angle triangle is simply identified with the right angle, 90 degrees, the box. AB is perpendicular to BC. The box means 90. Right angle exactly equal to 90 and directly opposite 90 degrees. You always find Mr. Hypotenuse all the time. So we say the square of the hypotenuse side is equal to what? The sum of the square of the other two sides. Okay. Then in some cases they will say to you, prove that a triangle is a right angle triangle. Prove that the triangle RAT, right angle triangle. How do we prove that a triangle is a right angle triangle? Okay, that's where this theorem comes into play. If the square of the longest side in a triangle is equal to the sum of the square of the other two sides, then the triangle is right angled. Okay, typical example of that, let's say you have this triangle and then I say this is 5, this is 3, and that is 4, and then I say to you, is triangle DEF a right angle triangle? I ask you that question. Is triangle DEF a right angle triangle? There it is. 5, 4, 3. So what does that theorem say? Let's just read it one more time. That theorem, beautiful theorem by the way, it says, if the square of the longest side in a triangle. So what we do is we go to the longest side. What is the longest? It is DE. So you grab DE on its own. Grab DE and just square DE on its own. So if you take DE and you square it, that is 5 squared. What is 5 squared, guys? Just DE on its own, because the theorem says if the square of the longest side. So let's check the square of the longest side. What does it give us? I didn't take 3, I didn't take 4, I took 5 because it is the longest in the triangle side. So 5 squared is 25. Thank you very much, Anati Maseti. You are setting us very well. Chini Anati. Good seeing you. All right, then if the square of the longest side in a triangle is equal to what? The sum of the square. Now we take the sum. Let's take now the sum of the squares on its own. So the other two sides are EF. Let's take EF squared on its own and add it to what? To DF squared on its own. That means, in other words, EF is 3, so 3 squared. And then DF is 4, which is 4 squared. And what does that give us? 9 plus 16. What's 9 plus 16, guys? Come on, tell me. What is the sum of the square of the other two sides? What does it give us? So we took the longest side, we found 25. Now we are taking the two sides, squaring them. That is 3 squared and 4 squared. So 3 squared is 9, 4 squared is 16, and then 9 plus 16 is giving us 25. That is the sum of the square of the other two sides. What can we then conclude? Because the square gives us 25, the sum of the square of the other two sides also give us 25, we can conclude what? Triangle DEF is a right angle triangle. Guys, don't ever write RAT like me. I'm just writing RAT because Most I told you what RAT stands for, right angled triangle. I'm just doing it because I'm lazy to write down right angled triangle. But when don't be lazy, my boy, my girl. You are not made to be lazy. When you are made to be sharps and doing good things, Don't forget the reason. When did you say to Italian? Ha 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 ha. It's Paloni accent for me. Ndungwane, you are funny, you. No, beauty, you have to. Here, when you conclude, you say triangle DEF is a right angle triangle. What is the reason? You say converse Pythagoras. Converse. You write as you conclude to state that triangle DF is a right angle triangle. You must write then the reason there. Converse Pythagoras. Okay, because what you did is you took the longest side, as they asked. The longest side squared gives you 25. So on its own, you can see that squaring the longest side gives you 25. Then secondly, okay, there's no reason that's needed for that. You are just checking DE. If you square it, what do you get? Then you take the sum of the square, guys, of the other two sides. You check what does the sum of the square of the other two sides give you. It also gives you 25, right? So now you compare, right? The equality of DE squared and the sum of the square of the other two sides will make you conclude that, oh, okay. Therefore, it means that this thing fits the mode of Pythagoras. So triangle DF is a right-angled triangle Y, converse of Pythagoras. Hey, the science genie. Thank you, my guy. Thank you, my guy. Really appreciate the roses there. 3 of them, I see them. And the you awesomes as well. And the TikToks and the roses. Aye. Thank you, my guy. Really appreciate you. Guys, Science Genie is the collaborative genius. He is the genie. You guys know Aladdin. Remember Aladdin? Aladdin, or all these nice cartoons where you would have a genie. You would rub the lamp, you rub the lamp, then poof, the genie appears. Guys, here we have a maths genie, a maths and science genie. He is the one that pops up. He will pop up. If you follow him, he will pop up on your live. He will pop up in your life and then pop up in the live, giving it to you, the maths and the science. If we are talking about one of the most hardest working individuals in these TikTok streets, his work ethic and a love for the work that he does, even for the students that he serves, is unmatched. I don't know of a man that works as hard as this guy. He's always live. He's always pumping, doing the things, so you must follow him, the Science Genie, and join his live. Science lessons are top tier. His videos, Tata the video. You will always find a video that will benefit you in that science and that math. So yeah, check him out when he does go live, and please do check out his videos. Go and like all of his videos, go comment on all of his videos, go and actually really absorb the content of what he conveys in his videos. You will learn a lot and you'll gain a lot, and you'll be better in the maths and the science for it. Together with my other friend Mr. TK and the Science Genie. Hi guys, to me those ones, they are the go-to guys. TikTok street, I respect for those two. You too much respect. Okay, triangle DF is a right angle triangle, guys. Converse of Pythagoras. Converse of Pythagoras is how we conclude. So we just proved, using this particular theorem, this one we use to prove that a triangle is actually in actual fact a right angle triangle. That's where we use this. So please guys, okay, you separate, you calculate the square of the longer side, check what you get. You calculate the sum of the square of the other side, you see what you get. Then when you can see that the values are equal, then it means the triangle DF right angle triangle. Okay, yeah, on Tatile, definitely. We goats, we already know, guys. You know, it's just that I'm talking now of up and coming people that have just sort of like landed on our TikTok streets most recently and most freshly. You know, Kevin Maths and Science has gotten his crown. He's goated that one. He's on another level. Tina, we are talking about these people that are now featuring, you know, and are doing the most. They are doing the most even for our Black Township kids, man. Like they're doing the most, man. You know, doing the most. So hey, I want to acknowledge them. Too much. The science genie and Mr. TK. Aye, you. Ah man. Okay, so let's continue. So I hope we are following here. Yeah, bro. I hope we are following here with the right angle triangle. So I think for now I am going to cap it. You know, I want to cap it. I want to cap it here. See if we can't look at some the problems. I think it's time now. Hey, we've been touching, we've been shakularing for a good time. Now I think it's time to look at some problems. Right, let's check some problems out. Let's apply. We've been learning, now it's time to apply. Okay, find the size of the angles A, B, C, D, and E in the following diagram. So let's just first, please guys, before you jump into a question and you start answering, you must first look at the situation that you have, so that as you are trying to find A, B, C, D, and E, you first analyze diagrammatically what you have here. So we have A, B, C. At the top, I can see A, B, C. This is a line, and I can see it's a line because there is an arrow. This arrow tells me something, right? Then I have D, E, F here. It is also a line. There's an arrow. These two arrows tell me something about A, B, C, and D, E, F. Does that make sense, guys? A, B, C, and D, E, F. I am told something because of these two arrows. What does these two arrows mean about A, B, C, and D, E, F? What do we know about A, C, and D, F because of the arrows on the lines? Beauty Lamini, you are truly beautiful in the mathematics because you are saying exactly what the arrows on the lines actually mean. Yes, guys, it means parallel lines. So immediately now the word parallel comes into the picture. Immediately you are like, between these parallel lines, I know of three major important relationships that exist between parallel lines. What are these relationships? There's alternate, and in your mind, there's N and Z shape for alternate. Corresponding, the F shape is in your head. Top, top, we are equal. Bottom, bottom, we are equal. Then there's U, which is basically co-interior. So those three relationships for parallel lines should immediately come to mind. Why? Because of the key diagram, which is A, C, and D, F. Because of the arrows, we know those lines are parallel. Okay, let's leave that. So in our head, that is registered, and already our fresh minds are already bringing to light the things that we know about parallel lines. Now let's move further and we look inside these parallel lines. What do we see additionally? What else do you guys see besides the parallel lines? Tell me. Let's not find what's equal and all of that. Let's first identify, as per the diagram, we said A, C, and D, F are parallel lines. What else? Do you see anything else besides parallel lines? All right. Do you guys get what I'm saying? Yeah. I want us first to identify and have a sense of awareness of the diagram that is before us. Before we start saying A is equal to this, B is equal to that, we need to first have a sense of awareness as to what do we have before us. So we first identified parallel lines. That's very good. Yes, Kazi D and Sbuta Sunday. Spooder Sunday, we are definitely spoodering it up in this Sunday, aren't we? We also have a triangle. Triangle what? BGE. Now, immediately when you look at triangle BGE, what type of triangle is triangle BGD? So on the basis of what we see here, these two lines, they mean something about this triangle. The type of triangle we have here is not any ordinary triangle. We know our triangles. We know the triangle types. Do you know why we know the triangle types? It's because we spent a bit of time much earlier on looking at the different types of triangle. So Tina, we have a very good awareness. This is still fresh in our heads, all right? And that's why I'm saying, guys, I'm here to do Euclid and geometry basics here. I'm not here to, basics, guys, basics. So you guys are on board. We have a isosceles triangle. Now we can move forward. We can move further now. You guys have answered the critical questions. Parallel lines and an isosceles triangle. Immediately, when we think of an isosceles triangle, our heads begin to think about things that are related to our isosceles triangle. Angles opposite equal sides. Remember, not so long ago, if we have sides that are equal, we can identify angles that are equal. Then there's also, if there are angles equal, we can identify sides that are equal. Sides opposite equal angles. So these are things that come to mind because of the isosceles triangle. Now, guys, we can move forward and we can go and answer the questions. The value of A, the value of B, the value of C, the value of D, and the value of E. Now, guys, many of you may start somewhere, some of you may start elsewhere, but as long as when we move from one thing to the other, it leads us to the correct answers and our reasons are spot on. This is what's important. Okay? We move from parallel lines. Okay, we understand the relationships. There are 3 of them between parallel lines. Fun. Then we move to triangle. Okay, I love the fact that Beauty Dlamini is even saying, besides the isosceles triangles and angles opposite equal sides and sides opposite equal angles, we also know that the sum of the angles of the triangle, they add up to 180. So this is all good information because it will all be assisting us at the end of the day so that we can resolve the answers to the questions. Okay, so let's resolve. Okay, and I can see some people are burning like a hot furnace. They want to answer. Okay, let's do it. Let's answer then. I'm eager to hear what is our first thoughts when it comes to finding either A, B, C, D, or E. What are we thinking about? What are we thinking of? Okay. Are we thinking of something looking at the triangle, or are we thinking of something looking at the parallel lines? Okay. Are we thinking of something looking at the inside of the triangle, or are we looking at something in reference to the parallel lines? So Sunflower is saying D is equal to 34 degrees. Now I want to check how true that would be. Okay, now D is here. I agree. D is here, right? But is it equal to 34 degrees, guys? Can we say that? Can we say D is equal to 34 degrees? There's 34. Is there any relationship that exists between this 34 degrees and this D? Okay, guys, there isn't, right? There's no relationship here, especially as it relates to this 34 degrees that we can see directly. All right, so we need to be careful about that. Okay, maybe someone would have thought that this is the Z relationship. No. Remember, if it was the Z relationship, it could be if we knew what angle A in totality was, because we could take this angle plus that and say it's equal to angle D. But we don't know A yet, so we need to find A first, you see? Because this A and 34 together are equal to angle D. That is the Z, the funny looking Z. Okay, so we can't start there. Let me back up a little bit. Someone else said something here. On 30, let's say the angle A is equal to angle B. Ooh, on 30, I love what on 30 is saying. Let's explore what on 30 is saying. On 30 is saying A, meaning this A, is equal to B, meaning this B. A is equal to B. Is on 30 right in saying A is equal to B? I think on 30 is. What is the reason on 30 for saying angle, for saying A is equal to B? Yes, on 30 is 100% right by saying A is equal to B. What is the reason? I want the reason now. A is equal to B. I agree fully. I agree like nobody's business. Okay, we need the acceptable reason. All right. Do you still remember the acceptable reason? Yes, Gazi D. Angles opposite equal sides. Okay, let's observe what we see in this triangle. GB is equal to GE. Then the angles A is opposite GE. B is opposite GB. These two angles, we say they are equal because they are opposite equal sides. So we can say A is equal to B, angles opposite equal sides. I love that. I love that. From the get-go, we can say that. All right? Then there's a relationship that exists between this angle, and that one. 1, 2, 3 of those three angles. I think someone already said it up top there and said A plus B plus 48 degrees is equal to 180. We give the reason though. What would be the reason? A plus B plus 48 degrees. Okay? A plus B plus 48 degrees is equal to 180 degrees. What is the reason for saying that? Yes, sum of angles in a triangle. So sum of angles in triangle. We said there's three reasons that we can use. We can say sum of angles in a triangle. We could say angle sum in triangle, or we could say int angles triangle. Any three of those reasons would be 100% fine. But guys, remember we said A is equal to B. So that means if we want, we can replace A with B, or we can replace B with A. It's up to you. So let's say we replace A with B. That means in the place of A, we write B plus 48 degrees is equal to 108. Then that gives us a chance to solve one variable at a time. Yes, N, very good. N is saying there in the comment section. We can then say, what's B plus B? These are like terms. Remember, when we add like terms, we keep the letter. We add the coefficients. So we have 2B plus 48 degrees is equal to 108. Please guys, the minute I lose you, you must indicate in the comment section, say you are losing me. I'm not with you. 2B is equal to, remember we isolate 2B when we are solving an equation because we want to find that letter. We take 48, it's positive. We transpose it to the right hand side. So the 48 degrees becomes what? Negative 48 on the right hand side. What's 180 minus 48? N has really told us there in the comment section that 180 minus 48 is 132 degrees. Then, of course, the 2 is multiplied to B. We want to solve for B. So if 2 is multiplied to B, we want to get rid of 2 we divide, we use the multiplicative inverse of the division, the multiplication inverse, which is division by 2. What we do on the left, we do on the right. Therefore, B is equal to, what's 132 divided by 2? That gives us a beautiful, brilliant answer of how many degrees? 66 degrees. We get that answer. That means, since we said A is equal to B, that means A is equal to B is equal to 66 degrees. Both of them are equal to 66 degrees. What do I do then? I go and update my diagram with the new information. Okay, very wise. We go and update our diagram with the newfound information so that when we relook at the diagram again, it can serve us with the information that is there. Does that make sense? We update our diagram with the new information that we've just discovered so that our diagram now is updated. The updated diagram can then lead us to even greener pastures. You'll say, so A and B is sorted. All that we need now is C, D, and E. Okay. Okay, guys, I'm sure you can see what you can see. You tell me. I love the guidance that I'm getting there in the comment section. People are really thinking, and I love the thinking process that is happening. Hopefully, we all understand how we got A and B. Now we all need to then move and find D, E, and C. Right? N is saying, isn't E equal to 34 because of the Z-shape alternate angles? All right, my question is, if you are saying that, my dear, E is equal to 34 degrees, Z-shape, alternate angles, who are you alternate angling with? I guess that would be my question. Who are we alternate angling with? Straight lines equal to 180 degrees. On title is saying ABG. Let's look at this. ABG plus angle A, yes, plus angle C, yes, is equal to 180 degrees. Okay, so Beauty Lamini and Ontantile are playing what you may call a tag team there. Then Sunflower then continued teaming with Ontantile, saying 34 plus 66, which is A, very good, plus C is equal to 180 degrees, angles on a straight line. These guys, you guys are tag teaming very nicely there. So let's just move with this trail of thought. So it seems like there's a consensus between these friends here. They're saying angle, so that's 34 degrees, meaning angle ABG. Very good. I love the idea. ABG, 34 degrees, plus the 66 degrees, plus the C. These are angles that lie on a straight line. These angles, they are adjacent next to each other. They complete a full straight line, which is great. And therefore we can say this angle plus this angle plus this angle is equal to 180 degrees. And you guys are 100% correct. We use the acceptable reason, angles on a STR line. Boom. All right. Then we can solve for C. Okay. 180 minus 66 degrees minus 34 degrees. Definitely 180 minus 30. Minus 64 gives you 80 degrees. Juice finished off that question like a pro. 66, negative 66 minus 34 gives us negative 100. And then 180 minus 100 gives us C, which is 80 degrees. So you guys tagged team very well to get angle C. We update our diagram. C is 80 degrees. I agree fully. Not a problem. Right, Ontadile. Okay, Very good. Thank you, guys. The C is definitely 80. I agree with all of y'all. C is 80, yes. Yes. Okay. Seems like we are getting reports on E as well. All right. Seems like we are getting reports chanting when Euclid was still Euclidean. Someone is saying Euclid was still Euclidean. Tobile Sibanyoni. D is equal to 34 plus 66 alternate angles. Tobile Sibanyoni, I agree with you there. The Z shape. Okay, that's one way of getting D. Look at this Z shape. Two of these angles make up this alternate angle with this alternate angle. This alternate angle with that alternate angle. Z shape, N shape, right? So yes, Sibanyoni, we can say 34 degrees plus 66 degrees is equal to angle D. Reason, alt angles. Then don't forget, guys, to state the lines that are parallel. AC is parallel to what? DF. If you omit to state the lines that are parallel, your reason is incomplete and it is not fully correct. Let me just say that to you guys. If you do not state the lines that are parallel in conjunction with alternate angles, your reason is incomplete and it is not appropriate. So please, guys, do you see this thing? You guys identified 34 and 66. They are alternating to D. D and 34 and 66 alternate. So 34 and 66. Can you see 34 and 66? This is the Z or the N shape, right? This one. It's the funny looking N. You see, if lines are parallel like this guy is equal to that one. Okay, Beauty Lamin, I hope you are with me here. This line and that line, if they are parallel, this angle and this one, they are alternate angles. Okay, so in the same way, 34 together with 66, they form the angle which alternates with D. All right. So therefore we say 34 plus the 66. That's why earlier on, when there was someone that said 34 is equal to D, I said it can't be. Why? We can't say 34, this angle is equal to D. These two, 34 and D, don't alternate. But 34 together with 66 alternates with angle D. There is the shape. All right? Yeah. Full angle alternates with this full angle. Then again, we can say 34 plus 66 is equal to D. Reason, alt angles. Then please, guys, when you say alt angles, you must write the lines that are parallel, because you are finding a missing angles where there are lines that are parallel and there's a relationship of angles that are alternating. Please, please, please. So 34 plus 66, that gives you I'm gonna wait for you. 34 plus 66. Therefore, D is equal to what's 34 plus 66? I know you know, but I just want to still get it out of you. What's 34 plus 66? Come on, guys. 34 plus 66. Thank you so much. You're 100 degrees. Thank you. You guys are beautiful. Update diagram. Now, do you see who's missing now? E is missing. E is the only one that is missing. All right. Now, I saw someone in the comment section say we can say C, or to get D, someone could have said C plus D. Very good on Tadil. If we wanted to find D, the other way to find D is to say C. We already have C, which is 80. We had gotten that from the previous question. we could say angle C plus angle D is equal to 180 degrees. What's the reason? Co-interior angles. Very good, Ontatile. And we could say AC is parallel to DF. Hi, Ontatile, you've taken me, my guy. Ontatile, Ontatile, Ontatile. Bangtatile, Bangtatile, Ontatile. All right, so this here, we could also find D by using co-interior angles. Very good, Ontatile. Now that we have D, we have B, we want E. Okay, 2 ways to find E. I am sure you guys can see the 2 ways. There could be 2 ways to find E, right? We could either use co-interior angles, or we could use what? We could use alternate angles, or we could use what? Angles on a straight line. Many ways to kill something, someone would say, but yeah, sorry guys. TikTok is very sensitive to certain language. All right. So we could basically approach this question in various ways. Okay. Many. There's co-interior that we could use here. We could use alternate, we could use angles on a straight line. But let me tell you this, whatever you use, if the maths is correct, if the equations are worked out correctly, and the algebra is fine, and the reasoning is on point, then I'm telling you guys, the marks are yours for the taking. So let me just use co-interior just because I can. Guys, you could use angles on a straight line. Okay, I'm not running away from that. I just want to use co-interior because I want to be different from what I've done so far. So co-interior, this is the co-interior we can see, né? Inside. We take 34, we take 66. That's the first interior angle inside this U. Okay, then we take 66, we add it to E as well, and then we say all of that is equal to what? 180. Let's do that so that we can just have another different approach. So 34 degrees plus 66, that's my first interior, plus this 66 plus what? Plus E is equal to what? 180. Then the reason that we use co-int angles, then we write the lines that are parallel. AC is parallel to DF. AC parallel to DF. Guys, I hope you will never be people that forget to write the reason fully. Ne? I hope not. So we isolate E, we take everything over to the other side. Okay, I know some of you would probably add the numbers on the left and then take over one single value, like my dear friend there with the beautiful ponytail, Nkanyezi. Yeah, Nkanyezi is shining like a star there in the comment section. 180 minus what? 66 into it, right? 180 minus 166. So E does give us what? 14 degrees. Okay, I'm trusting Ganyezi has actually obviously gotten us to the exact answer, and whether we use this or something else would still lead us to the same answer. I mean, if we did angles on a straight line, it would be E plus B plus D, D plus 166 plus E, which is equal to 180, angles on a straight line. We would still get 180 minus 166, which gives us 14 degrees. If we use the alternate angles, we would say 80 plus 66, right? 80 plus 66, is that true? Plus E. 80 is equal, to 66 plus E. Okay. 80 is equal to 66 plus E. We would still get the same answer. You see? Doesn't matter, guys, we'd still get the same answer. So there are many ways. So when your geometry eye has been trained very well, then guys, nothing will get you down. Let's move on to the next one. Okay, very good. I'm proud of all of you. You guys all did very well, phenomenally well. Let me just celebrate all of you. You guys did well. Okay, I loved the teamwork and the collaboration. Calculate x if b1 is equal to 108 and b2 is equal to 2x minus 10 degrees. What is this that's happening here? Because can you see? It's c, that's 2x minus 10 degrees, and they're saying calculate x if b1 is equal to 108. Calculate x. Okay, this doesn't make no sense. Yeah, because the statement is very much divorced from the what you see in the diagram. Calculate x if b1 is 108, because in this situation it's c2, that is 2x minus 10. Okay, guys, let's stick to the diagram. Let's forget about the statement. Let's stick to the diagram, because calculate x if b1 is equal to 108 and c, because it's angle c, that's 2x minus 10. It's not b2. Okay, so let's calculate x if b1 is 108. It's like that in the diagram, but c is equal to 2x minus 10. You see, you guys can tell now that I'm not doing this for the, it's not like I'm doing this. I'm doing this for the first time because I'm also shocked what's actually happening with this diagram. Okay, so I didn't work on it pre-hand. Yeah. So guys, let's do this. Let's solve this. Let's do this. We want to calculate x if b1 is equal to 108 and c, angle c, is equal to 2x minus 10. What is our thought process? What do you guys think? First and foremost, let's look at the diagram, analyze it firstly. It's very important to first analyze. So what do we have here? Triangle BCD. What type of triangle is it? It's an isosceles triangle. But it also has an exterior, which is angle 108. Did you see all of these things, how important they are? We have triangle BCD, it's isosceles. Then it has an exterior angle. It's a true exterior because it's in line with the side of the triangle. That's angle B1. Okay, it's an exterior angle. It's a true exterior angle. So what would you guys do? Okay. Nganyezi is saying angle C is equal to angle D. Juice is saying angle B2 is equal to 172. You guys are both saying things that are 100% correct, but I'm just thinking trail of thought wise, can we have a leading as to what do we then do? Beauty is like saying hence B1 is equal to C plus D. So that's taking from Ganye's statement. Beauty is connecting what Nganyezi said. So let's just take these two things. I'm going to move along with Nganyezi and what Beauty has said. Juice, I see what you said and I love what you're saying as well. Just want to collect the thoughts. So the first thing that Nganyezi said is that in triangle BCD, thank you Maski for the rose, triangle BCD, Nganyezi is saying angle C in this triangle is equal to angle D. And I love that Nganyezi is actually saying that. Why is Nganyezi saying that? You see, this initial awareness and identification of the shape and what we have is very important. This is an isosceles triangle. So angle C is equal to angle D for one reason. They are both equal to 2x minus 10 degrees. Why? Angles opposite equal sides. And if the reason is not there, the statement just lacks power. All right? So angle C is equal to angle D, which is equal to 2x minus 10 degrees, angles opposite equal side. I update my diagram. Then if I tie what was said by Nganyezi with what Beauty said, Beauty then says angle B1, the exterior. I love what Beauty said after that. Angle B1, the exterior, is equal to angle C plus angle D. Love this. The reason that we would write would be X angle of triangle. Exterior angle of a triangle. So B1 is 108. C is 2x minus 10. And D is another 2x minus 10. Now here we have an equation where our only variable is x. So then we can solve for x, because what did the question say? Calculate x if B1 is equal to 108. So it's very straightforward then what we can do to calculate that. We can say 108 degrees is equal to, we remove the brackets, 2x plus the x minus 10 minus the 10. That gives us 4x minus 20 degrees with the 108 on the other side. We transpose the negative 20. That's 108 degrees plus 20 is equal to 4x. We get 128 degrees is equal to 4x. We then divide both sides by the coefficient of x, which is 4. What we do on one side, we do in the other. Therefore, x is equal to, what is the value of x, guys? 128 divided by 4 gives us what? I'm seeing answers there in the comment section. Nganyezi is saying x is equal to 32. Is that a validated answer? Is the x value equal really to 32? Beauty Dlamini seems to also support it. So Nganyezi and Beauty, they tag teamed it up with that question, answering it very nicely. I see an alternative, all right, that's emerging from people there in the comment section. For instance, my dear friend Ujus there initially said B2 is equal to 72 degrees. All right, so Juice is using the idea of angles on a straight line to get B2. All right, then I'm guessing if angle C is equal to angle D, then obviously that's also going to be 2x minus 10 degrees. If we use that logical trail of thought, angles opposite equal sides. So we first use angles on a straight line, we use angles opposite equal sides, and then of course what we can then do from there is we can add all the angles in this particular what? Triangle. Interior angles of a triangle. Okay. Oh, Beauty is like, if only we could team like this, we could pass with flying colors in an exam. Yeah, well, Beauty, it's good to collaborate with others, right? Yeah. And this is one of the things that lacks, you know, in learners just generally, like this collaborative working together and effort. Because at the end of the day, if you would all collaborate, it would make life very nice and sweet. Okay, so yes, guys, if we use the angles on a straight line, we get B2 is 72. We use angles opposite side, we get 2x minus 10. We can then add these three angles together. That's an alternative way, and ultimately we still get x is equal to 32. You see, and we're writing a reason in every single statement that we do. B2 is equal to 72 degrees, angles on a straight line after subtracting 180. Angle C is equal to angle D. That's angles opposite equal side, 2x minus 10. You take 72, you add it to 2x minus 10, you add it to another 2x minus 10, equal to 180. You solve for what, guys? You solve for x. You still get the same answer, x is 32. Okay, yeah, so Mr. Juice, it works out nicely. Nganyezi, the reasons, I'm hoping, even though you are saying you struggle with the reasons, but I'm hoping you can see how easy it can also be to write the reasons, especially when you know what you are dealing with. Did you see how I said when we started this question, I said to you, what is in the diagram? That awareness helps a lot, because the minute you know, okay, there's parallel lines, you are like, okay, what are the things that we usually utilize for parallel lines? What angles or relationships exist there? Okay, we have co-interior, we have alternate, we have corresponding. You see? Yeah. And then you are like, okay, then those reasons might come up. Then we have a triangle. Triangle, we have the angles opposite equal sides because this is an isosceles triangle. And then we also have interior angles of a triangle. And what you realize is that when we were busy doing this particular problem, those things actually featured as part of our reasoning in some of the statements that we put in there. So if you write something new, there must be a particular reason that you are stating for writing that particular new thing. Same thing here. Okay, let's move on, guys. Let's move on. I think we get the point, right? We get the point. We get the point. Okay, so that was basically how we got number 2 together. All right, and also then I said alternatively, just by word of mouth, that according to Juice's method, could also have led us to getting the same answer. Angles on a straight line, we get B2 is 72. Angles opposite equal sides, we get 2x minus 10. Then obviously we take the 72 plus the 2x minus 10 plus the other 2x minus 10 equal to 180. Then we say those are sum of angles in a triangle, and then we solve for x. We should get x is 32 as well. Let's go to number 3. Calculate the length of BC. Again, awareness. What is this? What is this, guys? What is this thing that is before us? Because calculating the length of BC lies in first understanding. Kanti, what is this? Yes, Nganyes. This is a right-angled. Thank you. I was going to ask you. Right-angled what? Triangle. Thank you. Yes, Kachi. So it's a right-angled triangle. What do we have in this right-angled triangle? We have 4, we have 5, the 90 degrees is there, BC is unknown, AB and AC is known. So how do we find BC? You guys have 100% spot on said it. Theorem of Pythagoras. Theorem of Pythagoras. So if we're going to use the theorem of Pythagoras, Ukanye is like rushing to the earth. We need to make sure that we write our statement first with our reason. Very important, because we need to do a calculation, because this thing is saying calculate the length of BC. So writing the answer would not be sufficient. When they say calculate or they say determine, it means you need to show your steps to how you got there. So remember, what does the theorem of Pythagoras say? It says the square of the hypotenuse side is equal to what? The sum of the what? Of the square of the what? Of the other two sides. So we are going to say AC. Okay, AC. So we are going to say AC squared is equal to, okay, yes, very good. AC squared, the hypotenuse, because opposite 90 degrees is the hypotenuse. AC squared is equal to AB squared plus BC squared. Then we write our reason. Pythagoras. Don't forget the reason, guys. Okay, don't forget the reason. Then what is AC? 5 squared. AB, 4 squared. BC, that's what we want. So 5 squared is 25, 4 squared is 16, BC squared. 25 minus 16 is equal to BC squared. And then 25 minus 16 is 9, BC squared. You then go ahead and take the square root. All right, guys, when you take the square root on both sides, please, we as a matter of rule say plus minus the square root of 9. That plus minus is something that is true for an equation. If you are dealing with an equation, guys, writing the plus minus where there's an exponent 2 and you are taking the square root of that is true. That means BC is equal to plus minus 3. But we know that a length cannot be negative. It is a positive length. Okay, does that make sense? So it therefore is 3 units. Okay, very important, very, very important. So I want you guys to please don't overlook this thing, okay? Because when you do, for instance, let's be practical. When you guys are busy with right angle triangles on the Cartesian plane for trigonometry, your right angle triangles feature in different quadrants where your x and your y value, your opposite side and your adjacent side, they change sides. So being someone who is intentional about taking the square root on both sides and making sure that there's a plus and a minus, that's something you need to always take into consideration. Okay, very, very important. Yes, exponents of even numbers, very important on Tadil. Exponents of even numbers, two answers, one positive, one negative. So these are important. But then we conclude and say BC is positive 3 because an actual length of a side can't be negative. So we accept the positive 3 units as the answer, not negative 3. You can never have a length of a side being negative, okay? But the plus minus, when you take the square root on both sides in a equation, I beg you, make sure that you put plus minus, all right? That is to accommodate any eventuality whereby you may consider a negative answer. Obviously, for a triangle that has side lengths, you know that a length of a side is positive. But for a triangle on the Cartesian plane, take note. So as a matter of rule, the plus minus must be there, and then the selection must happen in accordance to the situation. Okay, but this is a statement that is correct according to geometry, and please, putting Pythagoras is very important. If you don't put Pythagoras, then it loses its power, this statement of yours. Okay, yeah. Let's move on. Question 4. Prove that triangle DF is a right angle triangle. Show which angle is 90. Prove that triangle DEF. Lily Spam. If you understand Nixie, the question is, when did you join? That's the first question. When did you join the live lesson? And secondly, let's start there. When did you join? Or makes no sense. And Gengoko, I can see by your statements that it doesn't seem like, oh, you hate maths as well. Man, I'm sorry about that. Oh, I'm sorry. I'm sorry, man. I'm sorry that you hate maths so much. I'm sorry. My heart bleeds for you, by the way. It really bleeds for you. Bleeds for you. Okay. Prove that triangle DF is a right angled triangle. Show which angle is 90 degrees. I just wanted to check. Lily Spam, do you actually do pure maths then, or did you change long time ago to another, or are you someone that basically is not even in school anymore, but it's just that you really just hate maths? If you can just comment in the comment section, I'd really appreciate it. So how do you prove that triangle DF is a right angle triangle? Remember, no, I am. So you are doing maths in school. What grade? What grade? Prove that triangle DF is a right angle triangle. Show which triangle or which angle is 90. Or you're in grade 9. Okay, so you have not as of yet, you have not as of yet chosen the subject, your subjects. Okay, so okay. By the way, like I feel for you, and I can actually empathize with you. Not sympathize, empathize. Because let me be honest with you, I was someone that hated maths in grade 9 myself. I think if you would have spoken to me in grade 9, I would have probably typed the same thing in a live lesson that I had been joining where someone was teaching maths. Probably like, hate maths, hate it, don't want to see it, and stuff. So I really feel and empathize with you. But for me, things changed in grade 10. I chose it, and then got to love it. And I actually did well in matric with my maths, and yeah, it changed everything, to be honest. And you see, now I'm actually happy helping people on TikTok. So Lady Spam, please don't feel it weird. Maybe you can send me a message on the side. You can DM me. I'd love to have a personal chat with you. Because yeah, man, people like you end up being the best students there ever were in maths. Okay. Anyways, let's move on, guys. Prove that triangle DAF is a right angle triangle. Show which angle is 90. Show which angle is 90 degrees. Yeah, someone is spamming me badly with the 67. I just need to check who it is. It's Dr. LeBron. Dr. LeBron is spamming me with 67. Okay, let me just block him because I think he's seeking. I think maybe he's seeking for followers as well. I'm sorry, man. I have to block you though. Sorry, my guy. I muted your account. Sorry, guys. Unfortunately, when you do such things, I have to get rid of you. I have to get rid of you. Prove that triangle DF is a right angle triangle. Show which angle is 90 degrees. Okay, so guys, when we look at this diagram, we have 8, we have 7, we have square root of 113. What's nice for you to do is to quickly check what the square root of 113 is, just like as per decimal, so that you can see, is this the longest side of these two sides? We want to first verify that. Are we really dealing here with the longest side? Because if this is the longest side, let's say it's greater than 8 and it's greater than 7, then it means we are in a pretty good place. And I'm thinking 100, the square root of 100 is 10. So if the square root of 100 is 10, this is definitely a value that is greater than 8 and 7. So this is the longest side. How do we prove that a triangle is a right angle triangle? Remember, we take the square, we take the height, we take the longest side. Okay, so we are going to say DF, we are going to square it, and when we square DF, we get 113, right? Does that make sense, guys? Then that's 1. Then let's take the other two sides and square them as well. Let's take the sum of the other two sides just alone and square them and see what we get. So if we take DE and we square him, then we take EF and we square him and then add the two together, which means 8 squared plus 7 squared. That gives us 64 plus 79. Okay, that gives us 64 plus 79. Let's be very careful. It's 64 plus, oh sorry, not 79, 49. What am I doing here? Doreen Beckford, how do you know the amount for the other two sides? Remember, Doreen, sorry, man, that was a mistake from me, the 79. Doreen, listen to me and listen to me very closely, right? There's a theorem. Let's first go to the theorem so that we can first have a foundational mathematical basis for saying what we are saying up in here. So here is the thing, okay? If the square of the longest side in a triangle, right, is equal, you see, they're saying the square of the longest side in a triangle. If that square of the longest side in a triangle is equal to what? To the sum of the squares of the other two sides. So what I've just done here is take the longest side, which is DF, and what did I do? I squared DF. So squaring DF, which is the square root of 113, right? That gives me 113 on the dot, okay? That's after squaring DF. Are we together? Then the part 2 of this question and answering it is taking the sum of the square of the other two sides. Now, if you remember, the other two sides are 8 and 7. So I'm gonna take the sum, but the sum of what? The square. So I'm going to take DE. That's how you understand the longer side. Doreen Beckford, how do we know that the square root of 113 is the longest side? Okay, we look at 8, we look at 7, and we look at square root of 113, and we compare. So if you grab your calculator and you press square root of 113, okay, take 113 and you take the square root of 113. What do you get? You should get a value that is bigger than 8 and 7. Okay, you're gonna get a decimal number, but that decimal number, okay, is a value that is greater than 8 and it is greater than 7. So that's how you know that the square root of 113, in other words, DF is the longest side. Okay, DF is the longest side. All right, please guys, don't say Doreen is slow and stuff. Please guys, don't let's not insult here. This is the last thing I want happening here in the life. Okay, yeah, the thing is, we are at different levels, and it's fine that that's the case. All right, I would not want people who maybe get things quickly to sort of like think just because someone is taking a bit more longer time to understand something that it must mean that this and that and this. Please guys, don't do that. Don't insult others. It does not spell well for you as an individual, because it says something about your character. And then we need to change that, mindset, please. Okay, so square root of 113, Doreen, I hope you get it now. I hope you're good, right? So this is the longest side. So according to the theorem that I just read to you, it says that if the square of the longest side, so we take the longest side, we square it, we get 113. The square root of the square root of 113 is 113. Okay, now I'm going to take the sum of the square of the other two sides, because I want to check if that is also going to give me 113 or not. So let's check this out. DE squared, which is 8 squared, is 64. EF squared, which is 7 squared, is 49. Sorry guys, I made a mistake initially and I said 79, which was absolute nonsense. So I apologize for my nonsense. Okay, I hope you guys can forgive me for my nonsense. Okay, I am human. So 8 squared is 64. 64 plus 49, guys, what does that give me? 64 plus 49. I want to check, does it give me 113? If it gives me 113, then checkmate. Checkmate. What's 64 plus 49, guys? Doreen, thank you so much. You are back with your forward. All right. So the square of the longest side is 113. The sum of the square of the other two sides also gives me 113. So that means that DF squared is really equal to DE squared plus EF squared. Do you know what that means about our triangle? It means that triangle DEF is a right angled triangle. That's what it means, guys. Triangle DF is in actual fact a right angle triangle. We have proved that it is. Now you're going to say to me, but how can you say so that you proved that it is? Guys, let's go back to the statement. It said, if the square of the longest side, do you remember we took the longest side, the square root of 113, and what did we do to it? We squared it, right? And we got 113 as an answer. So if the square of that side in the triangle, which is the longest, is in actual fact equal to what? To the sum of what? The squares of the what? Of the other two sides. What can we conclude then? This is like a if then. If you give me a gift of 20 roses, then I will teach grade 11 circle geometry. Does that make sense? If you do this, then I'll do that. So if the condition of square of longest side is equal to the sum of the other two sides is met, then we can conclude that that triangle we are talking about is not just any ordinary triangle, but it is a right angled triangle. That's why, having gotten the square of the longest side, having gotten the sum of the square of the other two sides, now we can see, but 113 is equal to 113, therefore triangle DEF is a right angle triangle. In this question, they were very specific as well. They said, show which angle is 90 degrees. So I want to ask you guys, which angle here, is it angle D, angle E, or angle F, which will be the 90 degrees? Where will the 90 degrees be? Yo, 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 homegirl, the schools are closed. Yo, 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 to you too, homeboy. Oh, my soul. People have time. And this individual just comes here and is like, FOTSEK. Love you too, buddy. Love you too. I know you want to join us. You know, these people that swear and they want to join us. I know you want to join us. Come and join, right? And just bring yourself down, humble yourself, come and learn. I'm happy to help you learn if you want. Okay, so guys, the angle that is equal to 90 degrees, very good. Sunflower, you're 100% correct. Lisa, you're 100% correct. Juice, you're 100% correct. It's definitely going to be what? Angle E. Why is it angle E? Remember, guys, the longest side, if it is the hypotenuse, is opposite 90 degrees. So angle E is equal to 90. That's what we say. We conclude, we say triangle DF is a right angle triangle. Let's not forget, we write the reason. Converse of Pythagoras. Oh, that reason is important. Converse Pythagoras. When you conclude and you say triangle DF is a right angle triangle, why are you saying that? It's because of the converse of Pythagoras. Then they asked for it. They said, show us the angle that is equal to 90. Angle E is equal to 90 degrees. That is the angle because it is opposite the longest side. It is opposite DF, which is the longest side. I hope you understand, guys, how straightforward this is. So this calculation needs no reason. That calculation needs no reason. The conclusion is based on the calculations. And then the final statement or the final conclusion is that triangle DEF is a right angle triangle. And the reason why that is the case is converse Pythagoras. Now, some of you are like, please repeat the reason. Guys, let's come back to the acceptable reason document. If the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right angle triangle. Reason, converse Pythagoras. This is the reason that they provided. Or you could write converse theorem of Pythagoras. The word converse, guys, means opposite. There's Pythagoras, there's the opposite of Pythagoras. Okay. Reverse. Thank you. Thank you, Ontatile. Beauty Lamine and Ontatile are saying it exactly as it ought to be said. Converse means opposite or reverse. Yes, the opposite of the theorem, guys. Okay. Okay, I don't know if my dear guy or girl is Micah, are we good? Sunflower, are we good? Sunflower and Micah. First there was Micah, then there was Sunflower. Are we good, guys? Are we good? McFeast, are we good? Yes, Micah, very good, Micah, very good. Yes, Sunflower, Sunflower, Sunflower. Yes, the sum of the squares is equal to the square of the longest side. The sum of the squares. Be very careful, Juice. Not the sum of the, it's the sum of the squares of the other two sides is equal to the square of the longest side. That's the converse of the theorem. Okay, let's look at this one. Prove that DE is equal to DF. Prove that what? DE is equal to what? DF. Alright guys, let's see, maybe you guys can help me out. We need to prove that DE is equal to DF. In order to prove that D is equal to DF, what must we find to be equal so that we can then conclude that DE is equal to DF? Here is the triangle. Let me see. Share the note. Which note, my guy? Yes, very good. We must prove that angle F is equal to angle E. So we have angle E, but we don't have angle F. How do we find angle F? So that ultimately we can then, after finding angle F, we can then conclude about side DE and DF on the basis of angle E and angle F with the reason that is appropriate. So how do we go about that? Yes, Kazi. Kazi D, sum of angles. Yes, beauty. We should use sum of angles in a triangle. We already have two angles. Come on, guys, go ahead and do it. I'm going to actually pin the person's comment that can actually write the statement, the reason, and then obviously lead us along. Come on, let's go. Okay, people are saying we need to use sum of angles in a triangle. So we first analyze, have a sense of awareness of what we have. What do we have? A triangle. Okay, what kind of triangle? We don't know yet, right? Until we can prove certain things, and then we'll tell you. But at least we know that the sum of the angles in a triangle is 180. So let's go. Statement, reason, answer, and then ultimately the statement that basically validates or supports DE being equal to DF with the appropriate reason. Let's go. Let's go, let's go, let's go. Okay, Sunflower, thank you. Angle E plus angle D plus angle F is equal to 180 degrees. Very good. That is the correct and true statement. What's the reason? 110 plus 35 is equal to 180. Be careful then, go Zasembo. Be very careful there. That statement is not correct. Go Zasembo. On Tatile, very good. Angle D plus angle E plus angle F, all three angles are equal to 180. Reason? Sum of angles in a triangle. Very good. Now we need to just proceed further. On Tatile, together with Sunflower, On Tatile has given us the reason, whereas initially Sunflower gave us the statement. So the statement coupled with the reason, Sunflower and Ontatile have basically given us at least the beginnings, the introduction of what we need to be doing. Juice, 180 is equal to 35 minus A. Okay, I don't understand. 180 is equal to 35 minus A. Okay, Ontatile says F is equal to 35 degrees. Okay. Beauty Lamini, 110. Very good, Beauty. The substitution. Okay, so initially I had that statement with the reason. Then the substitution, 110 plus 35 plus F is equal to 180. Very good, Beauty. Thank you. Then, yes, the substitution, Sunflower, is 100% spot on. Sioli is 110 plus 35. 110 plus 35 is equal to 145. So let's say the statement. Let's be very careful there, guys, with our statements right here. Okay. Yes, then Sunflower, we transpose. F is equal to 180 minus 110 minus 35. Very good. And then we solve for F. F becomes, like most of you are saying in the comment section, our F value. Doreen, be careful there. Doreen as well, very careful there. Okay, 180 minus 145 is not 45. Yes, Doreen, it's 35. Yes, okay, correct answer, 35. Okay, Sunflower, very good, 35. Zubaby, yes, F is 35. Yes, Nku Zasembo. Now we are talking Nku Zasembo. 35 plus 110 plus F. Okay, we add all three angles, including the unknown, equated to 180. Give the reason. Sum of angles in a triangle. Hi guys, we are working nicely. I love this. Right? Yes. Okay. If you set it up and first say angle F plus angle D plus angle E is equal to 180 degrees, and then reason. Sum of angles in triangle. Very good. Okay, angle D 110, angle F, that's what you want to find, E 35 degrees equal to 180. You transpose 180 minus 35 minus 110 is equal to angle F, and as you rightfully have said, angle F is 35 degrees. Okay, we're not quite done yet. So we find F, that's 35, update our diagram. So now we can conclude on the basis of that DE is equal to DF. What's the reason? What is the reason? This is where again we need to be careful. We're saying DE because we found that these both are 35. We can now conclude therefore DE is equal to DF. But on what basis? What is the reason? I'm going to write here in brackets. Okay, I'm going to send you back to the acceptable reason document. If you remember, there was a reason there that we would use. Goes assemble. Yes, sunflower. Sunflower, when you are the best. Sunflower is the best. Ngoza Sembo, we don't no longer. We laid, it is unfortunate that in 2014, we laid angles of an isosceles triangle to rest. Okay. The sides opposite the equal angles in an isosceles triangle are what? Are equal. The what? The sides opposite the equal angles in an isosceles triangle are equal. So we use sides opposite equal angles. So sunflower, I winner. You are the sunflower for the day, that's for sure. Sides opposite equal angles. Sides opposite equal angles. That would be the basis for which we say DE is equal to DF. We found the angle F being equal to angle E, which is they are both equal to 35 degrees. So then we conclude that side DE is equal to DF. The reason is sides opposite equal angles. Right? You wrap it up with that concluding statement, with that reason on the basis of the angles being equal. Sides are opposite equal angles. Okay. Base angles of an isosceles triangle, anything with we must put that to bed. John Trehano Jetta. We are not in school, man. Well, by you coming into my life, you are literally in school, my guy. School is not the four walls that you see there, the four walls of where you attend. School is also here, you know? Yeah, school is a mindset, guys, right? Wherever you are, it can always be school. And school doesn't necessarily have to mean behind the desk, learning maths and science. School, generally life in and of itself is a school. The school of life, that in itself is school. And hopefully you are continuously learning, reframing, and you are changing perspectives according to, a certain standard, which is very important too. So these people that are commenting all these things, man, they just make me laugh. Yes, beauty, ne? Let's be careful. We use this one. You see, we use this one when we want to say sides are equal on the basis of angles that are equal. We use the other one when we want to say angles are equal on the basis of sides being equal. Don't confuse them. Okay, beauty. I hear what you're saying. Okay, so on the basis of sides being equal, we say the angles, angle B is equal to angle C, angles opposite, equal sides. What are these angles? They are what? Opposite. Opposite what? Sides that are what? That are equal. So this one we write, okay, this reason we write on the basis of what? Of wanting to show that angles are equal on the basis of sides being equal. This one, if we identify angles that are equal and we want to say the sides are also equal that are opposite those angles, then we say sides opposite equal angles. So just, I know it can be confusing, and can I tell you something? It's only confusing because one does not get a chance to really do problems in succession and hammer it in. So that is why, for instance, for any, like even if you're a grade 12 learner, if you can go back to a grade 8 textbook or grade 9 textbook and go and look at like a series of problems that have to do with these, you could do it. You could AI generate questions like on Meta AI and just say formulate questions on triangles where I can actually find an unknown angle, and then basically you can just practice this out, okay, until you are fine, until you are sorted. Okay, yeah, practice makes perfect, practice makes permanent. Practice makes perfect, practice makes permanent. Yeah, on Tatile, you've hit the nail there on the nail. You've hit the nail on the nail. Look at this. Number 6. B and C are alternating angles equal to x. Is AB parallel to CD? Give a reason for your answer. Let me just show you the actual diagram. B, here's B, and C, here's C, are what? Are alternating angles. They are both equal to x. You can see that. There they are. Right? Now they are asking, is AB parallel to CD? To CD. By the way, there's no symbol of lines that are parallel, so we don't know. Okay, we don't know. B and C. B, meaning angle B, and angle C are what? Are alternating angles equal to x. They are both alternating angles equal to x, all right? Now they are asking, is AB, meaning AB, is it parallel to CD? So is AB parallel to CD is the question, and they are saying give a reason for your answer. So that's my question to you too. Is AB parallel to CD, guys? Is it? Juice is saying obvious parallel. Obvious parallel. All right. Why? Why are we saying they are parallel? Because it's not given to us that they are, but they are asking. Okay, they are asking. All right. Why is AB going to be parallel to CD? What would be the reason? If you say yes, they are parallel, what's the reason for saying they are parallel? Angle B is equal to angle C is equal to x. Okay, that's true. Okay, reason, alternate angles only at parallel lines. On Tatile, alternate angles are equal. Okay, guys, there's our reason. Some of you, I know, think it is obvious, but let me tell you this. It's not obvious, guys, right? And maybe it is, but we can say, the question is AB parallel to CD? You have this, you have that, you have this. That's x, that's x, that's C, that's B, you have A, that is D. And as I said earlier on to you, if the alternate angles between two lines are what? Are equal. I repeat, If the alternate angles between two lines are equal, what can you conclude? Then what? The lines are parallel. If the alternate angles are equal. So what are these angles? These angles are alternate. The reason why we say alternate, guys, is because of the position of these angles. It has nothing to do with whether they are equal, or it has nothing to do with them being equal or not. Being alternate has to do with the Z shape, the position of the angles in a Z or an N shape. This and that angle, we refer to them as alternate angles. Whether they are equal or not, they are alternate. 2. If they are actually equal, these alternate angles, just as you see them here, this angle is x, that angle is x, then as per this theorem statement, if the alternate angles between two lines are equal, then the lines are parallel. So the question is being asked here, B and C are alternate angles to x. Is AB parallel to CD? Give a reason for your answer. Well, you can say, is AB parallel to CD? Your answer is yes. AB is parallel to CD. When they say give a reason for your answer, do you know what your reason is? There it is. There it is. To prove that lines are parallel, I said it's one of 3 reasons. It's either you see alternate angles that are equal, or you see corresponding angles that are equal, or you see co-interior angles that are supplementary. So in this case, it is alternate angles equal. So that is why Ontatile's answer was pinned for the longest time there in the comment section. Why? Because I want you guys to actually appreciate the fact that Ontatile commented with the appropriate acceptable reason as per the acceptable reason document. Alt angles are equal. Okay, so there's always one of 3 reasons why lines are parallel. And so you need to take into consideration what is the shape and then what is basically the acceptable reason. Okay. People are saying, can you show us this paper so we can screenshot? Guys, this document, okay, is a document that you can find online. It is basically called the acceptable reason document for Euclidean geometry. If you go on there to Google and you search, or you can actually go ahead and download the exam guideline document for grade 10, 11 or 12 mathematics. This will be one of the pages that you will find, and it will give you not only the acceptable reasons for lines, triangles, but it will give you for quadrilaterals, it will give you for all the circle theorems that the grade 11s do, and as well as the triangle theorems that are done in grade 12. Okay, you can see most. There's also congruency here, okay, and then there's also similarity as well that you do for triangles, as well as grade 12s. We know about the proportionality theorem, okay, the prop theorem, as well as its converse, okay, which is not I think the converse the proof is not examinable, but the theorem, the proof is examinable. The converse is used though to solve problems, and that's basically where you need to also grasp and understand. Okay, similarity as well, okay, area rule, okay, or problems involving area. Okay, that's also quite important there for grade 12s. And then also Pythagoras is utilized in grade 12 geometry, you know. So yeah, the document itself, you need to actually have it handy, and then you must post it up. It must be there on the wall somewhere. Post it up there in the wall. It must be there. You see, this is my wall. You post it up on the wall, you have it there so that you can always know these reasons and when and how to utilize them. Okay, let's move on. Let's finish off these problems, because yeah, I think, okay, moving right along. Calculate x. I'm gonna give you guys a chance to calculate this one. I mean, this is yours, guys. This food You know, like I said, we're doing basics here, trying to get the basics down, guys. There's confidence that actually comes from you when you know the basics well. Okay, ontatile. What are you seeing here? You are saying angles around a point equals 360. Angles around a point. Ontatile is speaking about angles around a point. Okay. So what would you say then? Statement and reason. I see the angles around a point is equal to 360. And maybe people are asking which point? That point. Which angles? These angles. Around. It's like revolution. 360, my guy. 360. This angle plus that angle plus that one plus that one. Back to where we started. The addition of that should give us 360. We want to calculate the value of x. Our reason should be there. And then we solve for x and we get it. Okay. Yeah. Please do it. Do number 8 as well. Given angle ABD, which is 30, DBC 150. Prove giving reasons that ABC is a straight line. Okay. And then complete the statements. If the corresponding angles between two lines are equal, then the lines are. If the what angles between two lines are supplementary, then the lines are parallel. The what? If the what angles between two lines are supplementary, then the lines are what? Are parallel. Okay, if the what angles between two lines are supplementary. What's missing? What's missing? So let's first answer 7, answer 8, answer 9.1, 9.2. So you guys, I'm just going to give you a chance. With whatever you answer, you just indicate there in the comment section that it's 7 is equal to this. Okay, statement, reason, working out answer. Number 8, okay, proof giving reasons that ABC is a straight line. Then 9.1 and 9.2, fill in the blanks. Please go ahead, guys, use the comment section very well. Can you please zoom the question? Okay, let me zoom 7. Let us zoomify 7. Let us zoomify the 7. Okuhle, only Okuhle. Thank you so much, Okuhle. I can see you there. Okay, Okuhle has Okuhle that's up there. Yeah, Okuhle, I'm waiting for your follow. Okuhle, I'm waiting for your follow there. I followed you. Followed me back, please. There we go. Thank you. No, thank you for the follow, guys. Thank you for the follows. Really appreciate the follows. Follows are nice. Follow. I appreciate the follows. Those come more naturally than gifts. Yeah. Okuhle said it well there. 2x plus 120 plus x plus 35 degrees plus 3x plus 31 is equal to 360. The reason they're very good angles around a point. Yeah, because there it is there. The adjacent angles in a revolution add up to 360. We can either write angles around a point, angles around a PT, angles around a PT, or you can say angles in a rev. Rev means revolution. Okay, that's 100% fine. So very good. You see, the maths is being applied there. Okay, and then Ruben says x is equal to 29. Did we all get x is equal to 29 for number? Dlamini Beauty also saying x is equal to 29 degrees. Seems like we've got a consensus shared there of x values being 29. I think that point is missing like a letter. missing a letter like O. Yes, usually there is a letter there. Yeah, 100% on 30. 29 degrees, very good. Okay, yeah. On 30 seems like practice is practicing there. Okay, Juice is working through the problem. Seems like it's coming together. 360 is equal to 6x plus 186. So does transposing that 186 then dividing by 6 actually lead us to the infamous 29? We'll see. You'll let us know as it goes along. Okay, very good, guys. Number 7, well answered. Go to number 8 now. Prove that. Yes, Juice is coming along very nicely there. Given that angle ABD, remember, letter in the middle with the cap means this angle ABD. In other words, B1 is 30 degrees. DBC, we have a 2, that's B2, or we can say DBC. Now they are saying these two angles. Prove, giving reasons, that ABC is a straight line. How do you prove that ABC is a straight line? Okay, is it obvious? Yeah, you see, proving that something is actually what it is, what it claims to be. Yes, beautiful. I mean, it must. In actual fact, what angles are these? Yes, the two angles the adjacent angles should be supplementary. So this is not a situation of angles in a straight line. I want to show you here. Here is the acceptable. If the adjacent angles are supplementary, the outer arms of these angles form a straight line. I repeat, if the adjacent, the word adjacent means next to each other. B1 and B2 are what we call adjacent angles. They are angles next to each other. The word adjacent means next to me. Ooh, yeah. So B1 and B2 are next to each other. Oh, you'll find you're next to me. So it's angle B1 and angle B2 next to me. Ooh, yeah. So angle B1 and angle B2 next to each other, guys, you see. So angle B1 and angle B2, it says if the adjacent angles are supplementary. What does the word supplementary mean? It means add up to 180. So if the adjacent angles are supplementary, then we can say the outer arms of these angles form a straight line. Guys, outer arms means AB and then BC. Those are your outer arms. AB is the outer arm for this angle. BC is the outer arm for this angle B2. So if the adjacent angles, we find out that B1 and B2, the angle gives us 180. So we take angle B1. Guys, when we prove this thing, it literally is something that we need to do like the way this, in the following way. We must say angle ABD plus angle BDC. We then substitute ABD ki 30, BDC ki 150. What's 30 plus 150? Ki 180. So the two angles that are next to each other gives us 180. In other words, these two angles are actually supplementary. Therefore, we can conclude ABC is a straight line. What's the reason? Adjacent, there's the reason. Adjacent angles sub. Adjacent angles sub. This is the reason, guys, why we say ABC is a straight line. That's how you get your marks. This is how you prove that a line is straight. I know I don't want to be derogatory in my life right now, because if I actually am derogatory, I'll be in trouble with some of you students. Okay, yeah. We think all lines are straight, but they are not, Yeah, because that's what we find in geometry, but that's also what we find in life. Not all lines are straight, you know? So we always need to check. Beauty Lamine is like laughing. Not in geometry, not all lines are straight, and in life, not all lines are straight. So we need to actually, yeah, we can't assume as well, and we can't take it for granted. Okay, but guys, I'm showing you how to prove. You see, there are many things that I've shown you how to prove. How do you prove that lines are parallel? How do you prove that a line is straight? How do you prove that a triangle is a right angle triangle? Okay, these are things that you need to be aware of. The proof type questions. They are not difficult, they are easy, but they have a way in which you have to approach them. So this is taking the two angles and adding them. Here's the evidence that ABC is actually a straight line. Why? It's because the two side angles that are next to each other, which are called adjacent sides, are actually supplementary. Yes, beauty, you converse them, but please be careful that you use the acceptable reason to then support your statement, your concluding statement. Therefore, ABC is a straight line, adjacent angle supplementary. Therefore, AB is parallel to BC. One of three reasons. Alternate angles are equal. You saw those alternate angles. You saw that they are equal. Therefore, AB is parallel to CD. Corresponding angles equal. Therefore, XY is parallel to PT. Co-interior angle supplementary. You saw those co-interior angles that add up to 180. You see? Therefore, the triangle is a right angle triangle. Converse Pythagoras. Therefore, AB is equal to BC, side opposite equal angles. Okay, so this is for everyone. Okay, guys, to conclude, I think you guys are going to be sick and tired. This is for all grades, man. Okay, whether in grade 10, 11, 12, 8, 9, basics for all of you. So don't exclude. So all grades, this is basics for all grades. I will tell you when I go into others. I will tell you that, okay, this one Gengoku is not, is for grade 11 alone, okay, as we build. But for now, we are still relevant for all grades, okay. On Tatile, the cyclic, I will probably do, not tomorrow even. I'm intending tomorrow to get into quadrilaterals and because quadrilaterals are also problematic. Some of you did not do well in grade 10. Why? Because quadrilaterals, they sent you to bed. So we'll see, or maybe we'll start with the cyclic tomorrow. We'll see. Okay. What time? I think around about the same time as today. If not during the day, tomorrow. Alright, you just need to check out when I go live. If not during the day tomorrow, then I'll do it later on in the evening. But I can't be sure of time, guys, because my schedule is crazy. You see, even now, I'm not really on holiday. Busy with autumn classes, so I'm busy. I was already late minutes, but like I said, I try and upload this. This is grade 8, grade 9. It's foundational work for grade 8 and grade 9. Grade 10 foundational work, grade 11 foundational work. Okay, setting the notification does help. Yes, Sunflower, tell them. Thank you very much. Tell them Sunflower notification. If the corresponding angles between two lines are equal, then the lines are, you tell me, guys. If the corresponding angles between two lines are equal, then the lines are what? What do you know about the lines? Doreen says parallel. What do y'all say? Sunflower is sunflowering it up with parallel. Beauty is saying alternating. Really, Beauty? If the corresponding angles between two lines are equal, you are even told the corresponding angles between two lines are equal. So if the corresponding angles between two lines are parallel, then the lines are, so make sure that you fully read the statement. If the corresponding angles between two lines are equal, then the lines are Hi man, thoughts on WW3? World War 3, what is this? Hey guys, we are currently having World War 3 here in maths currently, guys. Can you just allow me? Seems like some things are just inevitable in happening. If the corresponding angles between two lines are equal, then the lines are very good. Yes, you guys are 100% spot on. They are parallel. Okay. Then 9.2. If the what angles between two lines are supplementary, then the lines are parallel. If the what angles, guys, if the what angles between two lines are supplementary, then the lines are parallel. What type of angles are they talking about here? Molester acute, nope. Const equilateral, nope. If the what angles between two lines are supplementary. What are the two angles that between two lines are supplementary? Then the lines are parallel. Hayin, guys, it's not adjacent. Hayin. If the what? Obtuse, no, guys. Alternate, no, not alternate. Supplementary. Supplementary. What does supplementary mean, guys? Revolutionary, no. Molester, no. Molester. My goodness, what kind of word is that? Molest. Okutle, you are a spectre from the gods. Okutle is a spectre from the specters. Yes, Okutle. If the co-interior angles between two lines are supplementary, then the lines are parallel. Guys, co-interior has to do with supplementary angles between two lines. Please. Okay, okuhle goddess. Iyadida yo. Beauty. Yeah. I guess it must be dithering, just like people's beauty, right? Beauty. I say I'm done with this math. Consti like he's done. How can you be done already? Maths literacy is better. Are you doing maths literacy, Consti? Which paper is this? No, this is just a paper for exercise. This is just a checking your understanding paper, okay? It's not an exam paper or anything like that. It's just an exercise paper, guys, just to check understanding for what we had learned, okay? No, if the co-interior angles, if the co-interior angles between two lines are supplementary, let's go back. You see, it's in the theorem statement. Yes, the theorem. If the co-interior angles between two lines are supplementary, then the lines are parallel. Remember, these theorem statements, you can get them in the exams where they write a theorem statement and they leave out certain words blanked out, and then when I have to fill in the missing letters, the missing words. So you need to, like I said, know the theorem statements. Okay, yes, Beauty. And if you do that, then you'll be sorted, you'll be fine. So guys, this document, get it as a matter of priority. Get it as a matter of priority. You see, for quadrilaterals, here, the statements, all of them. For quads. Yeah, for quads. Circles. You see? Circles. Okay. Yeah, we're coming here. Okay, I think tomorrow we'll jump in here. Yeah, we will take it one step at a time. Circles, very important. Okay, grade 11. Okay, tomorrow we'll take care of this one. Remember? Yeah. Yeah. We've got a meeting with destiny. Okay, guys. The easier the math is, the sweeter life is as well. Look at all the theorems. Okay, have them down to a T. This is nice. This geometry, the great. What is it? 11. It's nice, guys. This is nice. So this was a nice practice. I'm glad on Tatil. I'm glad that's actually validation for days. I love it. Okay. I love it. What is the difference between the theorem and quadrilateral? What do you mean the theorem and quadrilateral? There are theorems based on quadrilaterals. There are theorems based on triangles. There are theorems based on lines. There are theorems based on circles. There are theorems based on triangles. So these are theorems based on different aspects, different two-dimensional shapes. So you can't say to me what is the difference between, what is the difference between the theorem and the quadrilaterals, because you will get theorems on quadrilaterals, you will get theorems on triangles, you will get theorems on circles and so forth. These are different statements that are true that relate to those particular shapes. Okay, they are true statements. All right. Yeah, Sunflower, thank you. So I'm rewriting on the 15th of May. Currently have level 4. Oh, I see. Oh, so you are one of those learners that you're upgrading. Are you upgrading? Or you currently have level 4? You are rewriting. Okay. I want that deal. I think we should practice quads on our own. Yeah, well, I'll be doing circle geometry, but yeah, definitely take care of quads, right? Maybe I will revisit quads at some future point, but I think we'll jump into the circle geometry because I feel like there's so many people that are like, the circle geometry. Okay, we'll get the circle geometry up and rolling. Okay. But thank you so much for joining in the live, guys. 17.9k likes. I really appreciate the likes. Thanks for the taps, the shares. Thanks for the gifts, those that gifted, the roses, and so forth. The TikToks, the you awesomes, all of those things. They make a world of a difference when they do come. So thank you so much. But thank you also for participating more than anything else. Thank you for being active. Thank you for being around. Thank you for making the live worth it, Yeah, I think you guys really made the live so much more worth it just by being here and participating actively and responding as well. And also I saw some of you divert all the comments, the negative comments. Like I saw how some of you were diverting all the negative comments. People were coming here saying all sorts of negative things, but some of you were really doing a good job in the comment section, telling people to get off and to basically go to another live if they basically are disinterested in what is being shared here. Yeah, but I also appreciate the sensitivity and just the manner in which you guys conducted yourselves. So take care. Let's then meet each other again tomorrow. Like I said, I can't really determine the time, unfortunately, specifically, because as I said, it's a bit crazy for me. But when I do go live, hopefully you can see me and check me out. And lessons or these sessions, try to always upload the full sessions as they are, as raw as they are. I upload them onto the YouTube channel. Quality is not so great, but just rewatch it as it is with that camera phone quality. Cheers, guys. Have a good one, and I'll see you when I see you. Lots of love. Good night. Good night. Good night. 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 Night, guys. Nighty. Nighty. He's sleeping on the live. Who is sleeping on the live? Hi, man.